Okay, so now we've looked at substitution. I want to turn it around a little bit and try these couple of problems here. So we were looking at function machines earlier and thinking about the idea of a number going into a function. Maybe say, add 8 and work. So we say we put 3 in. We know we get 3 plus 8 is 11 out. So we tend to think about knowing the number that goes in. Sometimes we know the number that comes out and we're trying to work back the way. So we're doing a little bit of working back here to say, okay, if the answer is 20, say I've got a function machine, and in this case a is 3. So a is the number 3. So the question is, if I have, let's do this a wee bit neater. Say I've got 1, and it could be a couple of steps, could be different things that are going on. But say I had a function here, and I know that the answer going in is 3e, a is 3, and I know that the answer coming out is 20. What could go in the box? Okay, well, there isn't necessarily a way of, we think about our just normal multiplying, adding, subtracting, multiplying and dividing, okay? Then there isn't many ways directly to do that. So the idea is when we're going to have to maybe have a couple of things going on, maybe adding a number. So I want you to think of, for instance, I'll give you a wee head start on this. If a is 3, we'll say I picked multiplied by 8. Okay, well 3 multiplied by 8 is 24. So in actual fact, I need another function, I need another process to get back to 20. I know that 24 subtract 4 is 20. So really, what I'm doing is I'm saying multiply by 8 and then take 4 away. And that gives me 20. So what would be the expression? The expression would be, instead of 3, we've got a times 8. So that's 8a minus 4. How can I be sure? Well, I can prove it by substituting in 3 and then doing the calculation. 24 minus 4 equals 20. Okay, now how did I get 8a plus 4? I just picked a random calculation to do, which is multiply by 8. It just came into my head. I was being creative. But then what I used, the answer to that, is to think, well, how could I get to 20 from there? Okay, so you could start with a division calculation or an adding calculation and think, well, what do I do from there? Okay, so I'm going to ask you to try and think up 5 expressions of your own. When the second one here is we've got 2 letters, right? X is 2 and Y is 5, make up 2 expressions that have a value of 26. So how might we start that? Well, again, it's really a case of a little bit of trial and error in many ways. You might find a pattern. So say one of the ways to make things bigger is by multiplying. So let's say I've picked the number 4x. Okay, I'm going to start with that. Well, I can work out what 4x is worth because that's 4 lots of 2 is 8. Okay, now I know I'm going to have to add something onto that because 8 is not big enough. What have I got to add? Well, 26. Okay, 26 is a bit more than 8. It's about, say, 20 more than 8. And 20 in 5s is 4 lots of 5. So I'm going to put plus 4y. I'm just kind of trying to creep up a little bit towards it. And that's, I know that that's 20. Okay. But I haven't got 26. It's 8 and 20 is 28. So I need to take away 2 to that. So if I write minus 2 at the end, then I've got 26. Okay. So other ways of doing it. Let me try and do, because this is a wee bit tricky. I'll give you one more kind of go. Let's think about y first of all, because it's a 5 times table. I could just go something like, well, I know that 5 are 25. Okay, so that's 5 lots of y. 5 are 25 plus 1. How about that? Okay, so that's 5 times 5 plus 1. Do you notice that each time I'm writing down what my answer is, what I think the answer is, but then I'm going through the process of swapping substituting the numbers in to prove that it's the answer each time. Okay, there's a couple of examples of that. So I want you to have a go at that, see if you come up with 5 of your own for each of that. Okay, be creative.